Google says it will spend $15 billion on an Indian AI campus. That is really a wager that India can make AI cheaper for its own languages and users. But the grid recently left renewable electricity stranded. By the end, we test the number that decides if this becomes real computers. The first surprise here is not a building at all. It is a government deliberately trying to lower the price of intelligence itself, one subsidized GPU hour at a time. India's AI mission has put more than $1 billion behind computing capacity and homegrown AI. The point is not to outspend Silicon Valley. The point is to make access less dependent on who can buy a private cluster first. That changes who gets to experiment. The reported cluster already holds 38,000 GPUs. Another 20,000 are being ordered. A private cloud operator can aim at the richest customers. A subsidized pool can widen the funnel first. That is a different industrial policy. Fund the on-ramp, then let companies fight over what gets built on it. This is the rise. Compute becomes a shared input, like a new industrial port. The prize is not owning every model. It is making thousands of local experiments cheap enough to fail, learn, and try again. NVIDIA sells the picks. India is trying to build the workshop. Then the market runs into a problem most global models simply cannot solve with a simple translation button bolted on afterward, and that gap is worth real money. India recognizes 22 languages in its constitution. Its census records more than 1,500 more. A Sarvam founder said asking the same question in English can cost only 1/5 as much as asking in an Indian language. That gap is not a footnote. It is a bill that appears every time a product serves local users. That is why local model builders matter. Sarvam M is reported to have 24 billion parameters across 10 Indian languages. Krutrim trained on more than 2 trillion tokens across 22 languages. Sarvam has reached a reported $1.5 billion valuation. Krutrim reached $1 billion. Investors are funding language coverage as infrastructure. The deeper bet is demand, not patriotism. A model that handles local speech, forms, and customer support can turn more people into paying users. Lower inference costs make that easier. So sovereign AI here means a business case. Keep the useful layer close to the people who use it. Now comes the part that makes the whole strategy visible from space. The world's cloud giants are placing their biggest chips on this exact bet, all at once. Google's reported commitment is $15 billion over 5 years for a dedicated AI hub and a gigawatt-scale campus in Visakhapatnam. Reports describe it as Google's largest India investment and its largest AI data center campus outside the United States. The location is the message. AI capacity is becoming a global operating footprint, not a US-only annex. Google is not alone. Amazon says it will invest more than $48 billion in India over 5 years. Microsoft said it would put $17.5 billion into Indian cloud, AI, skills, and operations over 4 years. Those are separate checks with separate timelines. Together, they say the market sees India as a place to run workloads, not merely sell software. NVIDIA and Reliance have announced a 1-gigawatt AI data center in Jamnagar. The first 20-megawatt phase is expected by the end of 2026. Reliance said that phase would use GB300 GPUs and offer compute comparable to more than 75,000 H100s. The eventual plan can expand to 2 gigawatts. This is the hardware supplier meeting a local distribution machine. This is the ascent at its strongest. Government compute creates early demand. Local models give that demand a reason to exist. Hyperscalers bring capital and cloud tools. Chip makers bring the machines. Each piece makes the next piece easier to justify. It is a flywheel, but it still needs a socket. Here is the number. None of those glossy press releases can solve on their own electricity that gets generated but never actually reaches the customer who needs it. In the first quarter of 2026, India reportedly lost 300 gigawatt-hours of renewable power that had already been generated. The issue was transmission. The grid could not carry it to where it was needed. That is the crack in the AI boom. A data center does not run on an announcement. It runs on power arriving at the right place every hour. India holds 20% of the world's data, according to one report, but only 3% of global data center capacity. That gap can be read two ways. It is an opening for builders. It is also evidence that cables, substations, and reliable power must catch up before the promised capacity can matter. This is not a collapse story. It is a correction story. The scarce asset may not be the GPU. It may be the finished connection between a renewable plant and a data center. The winners will be the projects that secure both. A warehouse full of accelerators without dependable electricity is just very expensive furniture. That gives viewers a durable rule. When you hear a giant AI investment number, split it into 4 questions. Is the money committed? Is the campus actually being built? Is power connected? And does local demand use the machines? India has impressive answers to the first and fourth questions. The next years will test the middle two. So the payoff is 300 gigawatt hours. It is the warning label on a very real AI land rush. Google's $15 billion campus, NVIDIA's hardware, and every local model depend on that missing bridge between power and compute. If India closes it, this becomes one of AI's most important operating hubs. Next, watch the channel's documentary on MU.